Remember that the main purpose behind of securing the database is not a security appliance to install or just an isolation to a project to do. No, it is a group of interoperating, let's say, procedures, measures, politics to accomplish the safe and secure transaction. The main purpose is to deliver a service from a back-end resource. No, so this is the context of the database security generally to deliver a safe and secure service from a back-end resource. This is the main purpose behind of the database security. Thus, the working with transactions is a very sensitive unit. It's the most sensitive, let's say, in terms of knowledge, in terms of technicalities that we have to master in order to accomplish the context of securing your database-based project or database-based solution. The first security scenario you see behind of this working with transactions, actually the security to talk with is the conformity with the group of properties said asset. Those properties here, they are prescribed with a certain behavior that a transaction has to prescribe. Otherwise, we are put into a situation where the transaction might happen, might run, might be successful or successfully achieving its goal, but it is vulnerable. What are those properties here? Briefly, just a minute, I'm going to tackle those because we are aware about. So, tackling the definition of those four properties: the asset, the atomicity, consistency, isolation, and durability. Those are properties via which a way is imposed on each transaction. There is no exception. There is no exception here. All the transactions that they actually run onto our framework, onto our solution, onto our project in question, they have to actually to conform the rules set by those four properties: the atomicity, consistency, isolation, and durability. There is no exception. There is no case to say maybe yes for this, maybe no. No, there is no this way of thinking. Completely, they have to be conformed, all of them. The context here, we are going to describe those four properties via which to understand that they are compatible for all. We take the case of the transaction machine, via which we see a group of actions to do for one unique service, which is the withdrawal of money. I repeat this phrase: one unique service, but numerous actions to do. One unique service, but numerous actions to do. To check who is it, who is the person asking for the money to draw, to check actually if actually he has enough money to ask for. I'm asking for 1,000 riyal, but I do not have in my account, so I cannot get this 1,000 riyal. Or I ask 10 riyal, so I have enough money to get. So to check the availability of the balance, then the withdrawal has to happen. Then after an update to the available amount in my specific account, they have to happen, all of them, to finish this one transaction, which is the transaction, the withdrawal of money. All of those here, we are stating only four. Clearly, we are stating four actions to do, and those actions to accomplish one task. This one task, if it has happened fully, the transaction has happened, the one transaction. If they did not happen, the one transaction did not happen. Clearly, thus persistency here on relating the first action with the second, with the third, and with the fourth. And this example we have four only, but it's not a must to have to be four. There might be less, there might be more than that. Those are actions related to the same transaction. This is an atomic view. This is an atomic view of the group of the, let's say, versus the database, they are queries. So this is an atomic view of all the queries happening inside the same transaction. This is the first property that the transaction has to fulfill. This is the first property. Atomicity means either to see them all are just one or no. Ahmed Ismail. Ahmed Ismail just joined now. Good. أحمد إسماعيل كيف حالك؟ Okay, let's continue. Atomicity is the first acid property. Yes, it is to be the first, and this we insist on that. Yes, there is no order yet, but for the atomicity, we have to consider it as first because the list of the because of a common sense understanding here, the list of the queries that they belong to the same transaction, they have to be recognized from the beginning. Because of this view only, they have to be actually set as atomic at the first, let's say, level, or the first as prioritized before the isolation, before the durability, before the consistency. All of you that you came just now, why you are late? اعترفوا, why you are late?
مستر ما يصير
اسمع.
مسمى ندخل اول شيء، في مشكله ما اعرف ايش.
مستر
يس سعيد، يس احمد، اوكي، يس سعيد.
كان عندي اختبار.
في وقت المحاضرة؟
لا كان اختبار ذيك الساعة ورحت شي اخذ حاجة
تم
كنت
تم
ورجعت.
تم بالتوفيق ان شاء الله، ما يهمك.
تمراد انا حتى محاضره السايبر امس ما حضرتها، ما يدخل عندي الميت، كان توقع عده محاولات ودخل، ما اعرف من الشبكه من ويش.
لا ظهر لي، ترى يظهر لي دعوة اقبل مباشرة يعطيني صوت بعد. امس ما اعرف، امس ما ظهر اصلا، اللي يظهر لي يعطيني صوت في اذني يعني.
ظاهر مسوي مسمى دعوانه داخل الميت بس ما رضى يفتح يعني عندي.
لا انا من جنبي ما ظهر، نقصد انه من جنبي ما ظهر، هذا القصد.
ما اعرف يمكن في الانترنت مشكله او ايش.
somewhere. Let's continue because it's recorded now. So the second property actually after just fulfilling this atomicity, it's not just a definition here. The transaction has to fulfill this this property. Then after we talk about adopting the same transaction into the second property, which is the isolation. Sorry, which is the consistency. Sorry about that. Which is the consistency. But this is an example. We'll come to it just to define. Or we may take it now. We may take it actually. We may have a look at it just now. We have actually two queries to be executed within the same transaction, which is a procedure actually here. We are going to execute it later on. But later on, after generating the procedure, which is having this body here, if you can see my highlight now. Later on, we call the procedure just at one shot, or just one statement, passing the parameters required. Here they are, if you can see. I'm not explaining what does this procedure do because it's not the role to for now. But we haven't at least clearly seen here two queries, two parameterized queries, and those parameters we are receiving them from the header of the procedure itself. Later on, after finishing this full procedure and generating it, later on, once we need it, we're going to execute the procedure itself, just simply like that. So executing the procedure will lead to executing the list of queries available inside, which is a bulk of queries. In this example, we are having two, but we might have numerous queries inside. They are parameterized, remember. This way, we are seeing actually either to execute them all by making see by just executing this statement here, we cannot eliminate one of those queries. This is for our understanding, but for the computer itself, also, it would force the execution of those queries one by one, respected to relating them to those, let's say, parameters values. So even if there is any inference later on with another let's say procedure in another transaction, there will be actually correlation. Transaction one with the variable value one, transaction two, sorry, query one with value one, query two with value two, and so on. So there will be no doubt that there will be actually an inference, or there will be segregation of those queries. Even if they are segregated, they would be actually seen atomic for the same program, for the same transaction. So this is an example of an atomicity that we may consider. This is also another note is that this is also related to the .NET. It is an SQL Server pure transaction, but also we can consider that it is related to the .NET technology. Also, it can be adopted within any .NET IDE. So we'll pass to the second property that has to be also adopted after adopting the atomicity, sorry, which is the consistency. Yep. The context of the consistency, you see the example the same, which is the transaction, the ATM money transaction. Whether we, for example, we are going to check a balance, then after we're going to see, we check the person, then we check if the person has enough money in his account, then after we withdraw the money. Third query. Last query, which is the fourth, to update here, won't happen for any reason. An electrical short caused the machine to stop. What happens? The person has got the money, withdraw already the money, but his account was not updated. The amount did not get cut from his account. So what would happen? Would he actually be rich because of this electrical shortcut? Never, never. The consistency will consider that the transaction has failed and would find a solution, whether to just roll back everything, whether to come back to the initial state, rolling back, or just to continue the transaction once the situation is, let's say, rectified. So the consistency, whether all to be executed, what all the queries, all the tasks inside the transaction, the same transaction, they all to be executed or all to fail. Another view of the atomicity, but they are actually it is like that, whether to fail together or to succeed together. Here, that means that transaction, once we leave the transaction in between, when in executing the list of queries or list of tasks inside the same transaction, so there have to be no alteration to the original data if there will be actually a rollback. There have to be a rectification. There have to be a scenario via which the system has to understand how to roll back. Or if it is going to accommodate the task till the end, also there have to be a scenario via which the transaction will finish and everything will be settled. Consistency. Third property that have to be actually also adopted, which is the isolation. The context of the isolation here, we have two scenarios via which we are seeing two transactions to be executed at the same time, requesting the same resource and requesting the same, let's say, list of tasks or service from the same resource, yes, database, same entity, same table. So what would happen? The system would he do a prioritization of time, or let's say query 1, transaction 1, query 1, transaction 2, then query 2, transaction 1, query 2, transaction 2, and so on. No, never to happen this way. Never to happen this way. Actually, whether to happen to execute the full transaction 1 list of queries, otherwise there will be no interference. So if the scenario happens that the query, for example, query now, as per the example of the ATM transaction, we saw 4 queries to execute. 1, 2, 3, 4. Those are the 4 queries. We execute the first, check the account. Second, the amount, the balance he has, how much. Third, withdraw the money. Stops here, the system stops here and executes, launches a second transaction to check the balance, check the account, sorry, and then after check the balance. This is not an isolation. This is never to be an isolation. The isolation is not respected this way. So the isolation has to deprive the interruption or the interference of a transaction list of tasks or list of queries to just simply execute a second transaction for a reason or another. So the isolation has to eliminate such behavior. Isolation. So such behavior has to be eliminated. Fourth, without giving any more details because of Let's pass to the fourth property, and is the last from the asset list of properties. No, we were late enough. The durability, the durability. Actually, this context of atomicity, consistency, isolation, those three properties, if they are, for example, has been fulfilled and succeeded in working with one session, they have to be successful for all. If they are actually having an exception with one case, they do not actually have to adopt it for everybody. No, if it's an exception, it's an exception. Otherwise, if they are, for example, the atomicity, they are successful. Atomicity, consistency, and isolation, those three properties, they are successful for one account or one session when withdrawing the money from the specific, let's say, system or specific environment. They have to be durable and valid for all sessions, for all accounts. Otherwise, transactions would not be successfully, let's say, isolated, or let's say they are in a vulnerable state. Durability. The durability has to guarantee properties of the transactions that they are actually atomic, all, whatever the amount, the number of the actions to do. Durability has to guarantee that the list of queries belonging to a same transaction, they are either to succeed together, all, or to fail together, all. The durability also has to guarantee that the isolation of the list of actions belonging to a given transaction has to be not inferred, not intercepted. Durability. I like this word, you know. This is the summary. Or what I just said right now. Properties related to the transactions, they are not only the asset, but we see other views that they enhance the security versus the implementation or the deployment of both of the transactions, list of transactions, the transactions modes. We have in front of us 4 modes of transactions: the auto to be automatically committed, or explicit and implicit commitment, or the batch scoped commitment. What does mean commitment? The context of the commitment, remember here we were talking about the consistency, one of the asset properties. The consistency, we said the consistency, here it is, the consistency, the transaction has to be consistent. What does it mean? It means actually if a transaction has, for example, as per this example, we have 4 queries to do. If 3 happened and 1 problem happened to the system, so crashed. Thus, it has to be rolled back. All has to be rectified. Commitment here, the context of the commit, to make the system understand that what just has been executed. The word commit, to accept, to admit, to execute, to make effect on the system itself. Rolling back or canceling what has been started, it is not a commitment, it's the rollback. It's another case, it's another mode, whether to commit or to roll back. 2 modes, but we are going to adopt them within the technically prescribed modes, which are the auto commit, the explicit, the implicit, and the batch scope. Let's describe them now. So we know what is the mode. Let's describe them technically. The first mode, which is the auto commit, here the auto commitment, it is actually an individual query-based transaction. So all the types of transactions that they are built on top of one query, they are to be auto committed. What does it mean? It means the system automatically will admit that and will execute those transactions and admit the results onto the system. One query-based transaction that has an insert, so the content will be automatically executed on the entity in question. It has select, it has whatever the query is, so it would be actually automatically admitted on the object in question. Explicit and implicit, those 2 modes, the explicit and the implicit transactions, they are actually to use the context to indicate a beginning and an end of a transaction. Let's talk about the explicit transaction itself. It has to indicate specific, exactly and clearly on the program from where a transaction starts and where it ends. Then after, it has to specify whether there is a commit or there is a rollback on the statement, on the list of statements. So the transaction has to give a begin, has to give yes, specify an end, but at the end has to specify explicitly saying that yes, this transaction would be committed. Yes, this transaction would be rolled back. So by just passing this, the statement of commit or the statement of this rollback, no more or less. So this is an explicit mode. The third, sorry, which is the implicit. The implicit here, there is a small difference. Let me. Yeah, exactly. So here actually it has to be stated that implicitly that it is going to be started and explicitly indicated that this is the termination. Implicitly started, explicitly terminated. In the same way, a statement of commit to be passed at the end or a statement of rollback to be passed at the end. Depends. We cannot pass both. Remember, we are not playing here. So there is a mode to be passed, whether to admit or not. The fourth and the most complicated and the most widely used specifically for the web scenarios, specifically for the WW environments. The batch scope transactions. Here, actually, this mode via which we see an nested list of transactions being executed altogether, and there is a complication of what to do for the context of the admission. Do we commit all, or do we roll all? Do we roll back all, or do we commit some and roll back some, and so on? What is the scenario here? So this is the context of batch scope transactions. The context of the batch scope, why? Because we are going to handle transactions within others. So, sorry, yes, exactly. It's a context of nested transactions. But this way of transaction is applicable only for a certain type of transaction, let's say outputs, which is described as transactions with multiple active result sets. Here it describes and it describes the list of transactions that they have more than one output. Sorry. The very good example to explain you what is this multiple active result sets, MAS. The very good example to describe such type of transactions is the .NET environment. I'll come back to this point. Is the .NET environment. So regardless, why? Because we can. It's not why because, but I given you because actually I'm relating you to make you understand what is this context of multiple active result sets in mass. We are going to see more than one command or query being, let's say, transmitted within the same transaction or within one body of a transaction, let's say. We continue. So there is actually context via which we may use nested transactions, but amongst of them we use the save points. Actually, we use there is a technology enhanced by the SQL Server helping developers to implement transactions using the save points. The context of the save points is a reference point within the same program via which we see a point in time in the lifetime of the transaction where we can roll back, we can come back. The comeback here we need actually to indicate a point. There is this technology is for that. Using such technology where the mass is not possible, thus we cannot actually talk about the batch scope transactions in this scenario. So the batch scope transactions will not actually be successful when using the save points. because of the explanation what we're going to see now, describing the mass, the multiple active result sets. So let's take the first example, which is actually the non-mass, actually the non-multiple active result transaction. Here we can see let's say actually from the beginning we are going to create, and then after we're going to execute the query. So we are creating the object here, create the table given name T1, and then after we are having a list of queries to do. So then here we have actually in between we have one save point. So we have started here the transaction. We created an entity. We started some queries, 1, 2, 3, 4, 5. Then after we set one save point among the time, within the same body of the transaction, within the same body still inside. Continue. Let me pass to the next page. Still in the same transaction only. Still we have transactions to go. Then after here actually we are going to roll back for a reason or another. We don't want those transactions, those 3 transactions here. We don't want them. We have to roll back. So we can do that. So we can pass this rollback statement. Rollback to where? To the point where we just set, which we just set it up. Here it is, the save point 1. We saved a point upon the lifetime of the transaction, the body of the transaction, that we are able to roll back to. Then after we continue the transaction until the end. Then after we have a commitment here to pass the statement to commit all. This is a non-mass, this is a non-multiple result sets. Actually, we have only one list of queries to do. That's it. We are not having more than one command. This is a query, but it is not describing the context of the multiple active result sets. Let's see the second example here, which you clearly see the difference. So here we have numerous queries, yes, and here also this next example we'll have more than one query. See, select. Actually, this is for a mass transaction. We have a start. We'll indicate the beginning of the transaction. So we have 2 commands in the body of the transaction. Command number 1. So the command body holds this query, this list of queries. So I'm going to insert the values into the entity we created already, which is this T1 here. We are going to insert those values. Number 1, select, and so on. Let me pass to the next page. We generate second command, SQL command here. Actually, this is a .NET specified command. SQL command cmd2. And to this cmd2, we are going to do whatever we want. Actually, here for this example, we're taking only one query, which is an update. Any questions?
يا مستر
Yes, Saeed, any questions?
ممكن تخلي 10 دقائق من وقت الكلاس عشان تفهمنا سؤال الاسايمنت لان ما فهمناه.
ما يحتاج 10 دقائق اقل، ساشرحها ان شاء الله.
يلا زين.
ان شاء الله. So in conclusion, what we have an update, or we have in the transaction number 1, command number 1, we have selects or inserts. We have list of queries, but to the command 1, cmd1 here, list of queries. To the cmd2, command 2, we have other list of queries. Execution, what would actually lead us to do? In this example, we are generating a transaction. Here it is the transaction. We are creating a transaction. And to this transaction, we are relating the cmd1 and the cmd2. Both of them, they are related to the same transaction, run. Good. We continue to the next page. Here, we are going to either try to execute and let's say save the content or not. So we are going to, for a reason or another, we're going to execute because actually we know the cmd2 has an update only. cmd1 has list of insert and selects. This is the CMD2 what it has. And this the CMD1 has actually already we saw it. It has an insert. It has a list of selects also. So the commitment or the transactions to what command we're going to pass. Can you answer? Extra one mark. And finally, إذا تجاوبوني على السؤال. If you can answer this question. The commitment or the rollback, the mode here, we're going to admit it, whether it is a commit or just is a rollback. On which command, CMD1 or CMD2? Here, in this example, clearly the statement is tran.commit. So we are committed. The commit on which command, CMD1 or CMD2? Can we separate them? Can we segregate them? Answer is no. We have the object tran. What it covers, all, whether all or not. So multiple result sets here is seen through the two commands we have, because the command 1, CMD1, it has its own execute non-query, and the CMD2, it has its own execute non-query. We know all of this. So whether to admit all or not, multiple active result sets, mass. This is a mass transaction where we cannot generate save points. And this is a bash scoped transaction. The mode of this transaction, tran, it's bash scope. Why? Because we are covering the scope. Actually, it covers more than one, let's say, query or command. It's not query, but more than one command. Any questions, please? The last part actually in this unit, which is actually the context of the isolation. Scenario of the isolation. We are isolating transactions also. But the scenario of the isolation here, it is not the definition of the word isolation in the computer security or the digital security. We are isolating the system. Literally, it means that. But there is a scenario via which we adopt the isolation, via which we apply or implement the scenario of the isolation. We see in this table here we are having a list of isolation levels. By the word level only, you understand that we are talking about a limit via which we enhance or support the isolation. We are not going to put it at 100%. Remember, 100% isolated system is a useless system. Thus, even a transaction 100% isolated transaction, it's a useless transaction. It would not run. The isolation is the purpose of to make the transaction run as perfect as it has to. To make you understand more what does it mean to make a transaction run as perfect as it has to be, a transaction actually it has to have an isolation level. Let's take the example of the serialized or serializable transaction level. Taking the example of the web environment here in the scenario example given to us, it prescribes the isolation on the web as a case study. Yes, here it is. The serializable actually, it is a serializable mode. Actually, it is a context of just passing queries in a series mode, no more, no less. But why we are going to talk about a series of queries to be a transaction using, let's say, OJ is built on top of list of queries to be seen. The content of this transaction to be seen segregated into a list of queries, one after the other. The system will do that. It will be actually done in an obscure mode. Because of the, if we take care of the, if we see the environment here we work on, which is the web, nothing is controlled. We take the example of the YouTube or the Facebook or any enormous data management system, let's say, or a big data management system or something like that, the quantity of data managed per second, it is not something that we may expect even by the system itself. Data might be new, might be old, but the number of data and the origins of data that can come at the same time might prescribe transactions regardless of talking about the type or the model of the transaction to be passed per second or per the same instance per entry. Here it is. Here it is. Just to just to push the list of queries passed by the same transaction just in a sync mode, just to pass the one after the other, no more, no less, to be synchronized, and to push them to be seen by the system or the systems in plural, the transaction content, to be synchronized one after the other, to be actually pushed one after the other, and the system would be synchronized using the content of the what has been communicated. This ensures that the application made up of multiple units. Any questions, please? Actually, this is for your next class, which is actually covered. All what we saw is all what we saw today. It's cover next quizzes content. And if you hear your name, please